see this. So actor.create, we're going to create the actor based on the physics, shape or whatever, and we've of course got to give it the scale. This 0 is the density. I forget what that means, but you know what, you can have a look and read in here. Right now it doesn't matter too much, you can look that up in your own time. And we'll set the matrix of the actor, of course, we've got to set the scale and the matrix so that it's lined up with our object when it's loaded. You want to set a few variables on the actor, for example obj. You want, basically when an actor collides with another actor, there is something called a physics callback. The physics callback knows nothing about your object, it knows about the actor. What you can do is you can store a pointer to your object data inside the actor, and this is what this is. So the actor.obj stores a game.obj pointer. Of course, you can use a static cast, a C++ static cast, to sort of like that, if you needed to. You don't do it here, of course, that's just stupid, to get your Tesla coil back from that. But enough about that. We also can set the user data for the actor. Now usually this is a bit weird, I set the user data of the actor as the actor. Don't ask why, I'm not going to explain it, but for now it doesn't really matter for this one. But we can also set the actor group, and because this essentially is a static object, I'm just going to use the already defined AG static actor group. So there we have it, and then we get our own params, get custom params, and we have set it up. So that's probably the more annoying part. Now we've got our next important function. We've got our update function. Personally, I think functions should always have a capital letter to start, but whatever you're happy with. I'm just using because I'm inheriting from Esenthel's code, I have to use the lowercase. But who cares? So in this case, we're just going to return true because we don't want it to be destroyed. Say for example you wanted it to disappear from the map when the player presses a button. You'd go if kb.b kb underscore t, say you press the T button, you want it to disappear forever, then you can return false, something like that, or whatever. Once this update function returns false, the object gets deleted. We're going to leave the object update function like that just for now, because what our goal is right now is to first get our object to a point where it at least draws in the world. So the next thing we do is we do our draw prepare function, which returns an unsigned integer. And we first have to do is check if the mesh is valid. Now, if you ask me, if the mesh is not valid, then something's gone wrong and the game should crash anyway. Because why should the mesh ever be valid? In the case of my Tesla coil, I should always have a mesh. So I am sort of conflicted whether I should actually waste the processing time of all these if statements to check if it's valid. But in this case, I'm going to check if it's valid. We're going to do it anyway. But we don't just check if the mesh is valid. We check if it's in the frustum. Wait, I take that back. I remember why you must check the mesh is valid. You must check that the mesh is valid is because if you don't, it might go out of scope of the Esenthel streaming in worlds and whatnot, and it might actually not be valid, and then it might become valid later again when you get closer to it, something like that. You need to check it's valid. Sorry about that. But anyway, next thing you need to do is you need to check if it's in the camera frustum. This is called frustum culling. You don't want to draw anything that isn't in view of the camera. It doesn't make any sense whatsoever. So, strangely enough, the function for that is frustum, and what we need to do is we don't check that the mesh is in there. We check if the mesh's bounding box is in there. So that's really simple. We go mesh, use that operator, and it is box, mesh box. But then of course we have to give it the matrix, and the matrix is the scaled matrix, and then that's it. So now we have our draw prepare function, and it'll only draw if the mesh is valid and if it's in the frustum. What we need to do now is we need to lock the material. Basically what happens is once you lock a material, whatever you draw after that lock will be drawn with that material. So to do that we go material lock equals, and then our material, it's a material pointer. Now to get the actual material now, we need to use the parenthesis operator. That will return the actual material rather than the material pointer. So now we've locked our material. Now what we want to do is we want to draw our mesh. And we have to draw it to the scaled matrix. I've done something silly. I always do this for some reason. Forget to put those on. Is that what I called it? Scaled underscore matrix with this lowercase. And there our, it's not quite finished actually. Now what we need to do is we need to unlock the material. If you're going to draw something else, or you're going to change the material and draw another part of the mesh or another mesh, then you don't need to do that, you just need to change the material. But we want to set this to null. So we haven't got our material locked there anymore. And that's our draw prepare function. Now let's quickly make our draw shadow function. I'm going to copy that one and I'm just going to change a few things because it's very similar. Shadow, draw shadow, void, and we still check the mesh and we check the frustum. All we do, however, is, in this case, we draw shadow. Now I've just had a thought. I'm wondering why you have to lock the material for draw shadow. That's the way I originally learned it, by following the Esenthel tutorials. I haven't actually checked what happens. You know what? That's something you can do. Try and draw shadows without the material and see what happens. I'm not going to do it right now, just for the sake of this video. So we've got that draw shadow function down. There's just two more functions here. This pos and this matrix function. I'm just going to write them in here because I really couldn't be stuck. That is going to be matrix.pos. So the position is stored in the matrix, not the matrix 3, the matrix equals pos. And in this case, oh, this one's a bit more. Oh, of course. Matrix, scaled matrix equal pos equals pos. You shouldn't do this in line. It's a bit silly, but you know, I really don't care for this. For some of this, the way we set the matrix is we've got to do exactly the same as we did in create, because we've got to set the scaled matrix as well now. So I'm just going to do it here. Get rid of that for now. Except we're now using this new matrix value, and that's all happy joy land now. Actually, I will just move it in line because it annoys me having functions inside the class like that. Okay, so we are finished. Now our Tesla coil obviously is not going to be shooting any lightning bolts right now, but we're just going to test that it works first. So Let's go to our... Oh, I have forgotten one thing, but I'm not going to worry about it. One sec. The path obstacle. I have not set that yet. But we won't worry about it just yet. Let's check if this works. So let's go to the world. Let's find our Tesla barrel. And let's drop it in there. Dang, that's a big barrel. Test coil, yeah, looks all good to me. I'm gonna play this and run this, and let's see if it worked first. Okay, so I just had a few compile errors there before, nothing too big. One thing I forgot was the draw shadow. I forgot to put the matrix in there. Another thing was I had the draw shadow was I actually had draw prepare, which is a double up. It should have been draw shadow, and the rest was other just normal bits and pieces, typos. So I think that was about it. So let's actually go in this time and see it in game. Okay, so let's go in here. Let's navigate to the place that we put it. And there is our Tesla bottle thing. So you can see it's got physics, which seems to work fine. It's in the place that we put it. Of course, right now it's not shooting electricity at us because we've just got it to a point of static electricity. To be a static object. You can see it's drawing its shadows fine. Another thing I was saying before about the path obstacle that I was saying, oh, I forgot to put that in. Well, if I turn on my debugging, by the way, that's something I made myself, so don't expect to find that automatically in your game. It already has done it without me having to specify. You only need path obstacles when you're doing something like maybe, like for example, this door opening and closing, you want to change the path. In this case, my door will open automatically, so I don't want to change the path. But if we go and have a look down here, we can see that the green path mesh is blocked here. That's because this door is locked, it's not going to open. My door and the switch here are other examples of these game objects. And basically, you just take the game object and you make it to be whatever you want using those sort of techniques. See, I'll show you now. If I open it, what happens is I use that path obstacle variable that I don't need for the Tesla coil, and it will automatically recreate and uncreate the thing. Here's another game object that I made, just a pickup. As I said before, if you want something to disappear from the world, you tell it to return false in its update. This one does just that. After you pick it up, returns false. So there's some examples. You can see this is working. I think I'm going to end this tutorial here and make it part 2 to actually get things like the electricity for our Tesla, whatever you want to call it, fuel drum, Tesla fuel drum. And yeah, so basically I hope you enjoyed that. I'll bring part 2 to you another day. However, this should give you a fair bit of information to get started. Feel free to ask any questions. Like it if you like it, subscribe if you feel like that. And I hope you learnt something. I'll catch you later.